Hello everyone, welcome to Demo Cloud. So today we are going to talk about virtual private cloud peering connection between your own VPCs. So what exactly is VPC peering? So a VPC peering connection is a networking connection between two VPCs that enables you to route traffic between them using your private IPv4 or IPv6 addresses. So instances in either VPC can communicate with each other as if they are within the same network. So you can create a VPC peering connection between your own VPCs or with a VPC in another AWS account. So the VPCs can also be in different regions. So it is known as inter-region VPC peering connection. So today I'm going to show a demo on how to create a VPC peering connection between your own VPCs. So let's go to VPC under networking and content delivery. So here what we are going to do is we are going to create two instances in two different VPCs and then we will make the EC2 instances communicate with each other using the VPC peering connection. So the first step would be to create a VPC, create a subnet, create an internet gateway, create a route table, and then launch your instances in your VPC and then have a VPC peering connection. So let's go to your VPCs. So let's create a VPC. So let's name it as source VPC, and the CIDR block would be 10.0.0.0/26. So as you can see here, 10.0.0.0/26 has around 64 IP addresses. So the easiest way to check this and also to identify the starting IP address and the ending IP address is to go to the subnet calculator here. So enter the IP address as 10.0.0.0, and since we told the CIDR notation will be 26 bits, keep it as 26. And as you can see here, so there are 64 IP addresses available in this range. So it starts from 10.0.0.0 to 10.0.0.63. So once you create a VPC, so we have to create a subnet. As you all know that the VPC spans across the availability zones in a region, but yes, you have to create a subnet as each subnet should reside within one availability zone, and also you are going to launch instances in that particular subnet. So since there are 64 IP addresses, let's assume we are going to create 4 subnets. So that means this 64 IP addresses divided by 4 comes around 16 IP addresses. So when you say 16 IP addresses, in order to find the exact CIDR block for 16 IP addresses, the best way is to go to the CIDR Wikipedia page here and see the 16 IP addresses here, and the CIDR notation starts from 28. So for example, as I said, 10.0.0.0/26, we have around 64 IP addresses, and we are planning to create 4 subnets. So each subnet will have 16 IP addresses. Since I told you 16 IP addresses, here the CIDR notation will be /28 format. So just write /28 here, and it would start from 10.0.0.0 till 10.0.15, and again it starts from 16 to 31 and 32 to 47 and 48 to 63. So it starts from 10.0.0.0 till 10.0.0.63. So let's verify here. So this is what exactly the CIDR range is showing here, right? So let's go to VPC here. Let's create. I am also going to create a target VPC. So for this, I would mention the CIDR block as 10.1.0.0/26. So again, as I mentioned, For 10.0.0./26 has again 64 IP addresses. So let's assume we are going to create 2 subnets. So that means each subnet will have around 32 IP addresses. So for 32, again let's go to your CIDR Wikipedia page. You can see here it starts with CIDR notation /27. So just place /27 here. It starts from 10.1.0.0 and it ends till 10.1.0.63. So again let's go here. Let's put as 10.1.0 and 26. As you can see here, it starts from 10.1.0.0 to 10.1.0.63. So it's very easy and there should be no confusion. So whenever you try to divide your CIDR block into different subnet ranges, so please go to the subnet calculator, and at the same time please open the CIDR Wikipedia page, so which can easily tell you the CIDR notations for available IP addresses. Right. So since we have created source and target VPCs, let's go to subnets. So let's create a subnet called source 1A, because I'm going to place this in the source 1A, and this will be added to the source VPC. And let's put the CIDR notation as 10.0.0.0/28. If you can see here, 10.0.0/28 comes under this CIDR block. Okay, so let's put it as source VPC subnet create, and let's create one more subnet called target VPC subnet, which will go to target VPC. Let us place this in South 1B region, and let's have the notation as 10.1.0.0/28. As you can see here, this it's 10.1.0.0. let's verify this here, 0.0, and if it's right, so this would be 26, this would be 28. Right, create. So we have created a source VPC subnet and we have created a target VPC subnet. Now let's go to route tables. So the moment when you create a VPC, by default AWS assigns you one route table, and by default route table which assigns is called main route table. So let's click here. Let's name this as target route table, target VPC route table, and let's name this as source VPC route table. Right. So if you click on source VPC route table, if you see the routes here, so all the traffic destined to 10.0.0.0/26 will be only communicating with all the instances which are in this VPC range, because here the target is mentioned as local. So if you see here, we don't have any route table mentioning the internet gateway, because we need internet gateway to communicate to the internet. And if you want to launch your instances in your VPCs, you have to make sure that your VPCs have subnets and route tables which are able to communicate your internet gateway. So before we do that, let's go to internet gateways. Let's create an internet gateway. Let's mention as source VPC internet gateway. Create, close. Let's create one more gateway, target VPC internet gateway. Create, close. Now let's attach these gateways to the respective VPCs. So this should be attached to the source and this should be attached to the target, right? So since we have integrated with the internet gateways, let's go back to route tables once again, and in order to make sure that the traffic which is destined to o.o.o.o/o should be reaching to the internet gateway. So let's do the same thing for your target VPC as well. Click on edit, add another rule. Let's add, so all the traffic routed to the destination from the subnets will go to internet gateway. Save, right? And also make sure that when you create a subnet, click on any one of the subnet, go to subnet action and make sure that you enable this option. So what happens is when you launch your instances in the subnet, automatically AWS will assign you an IP address. Save, close. Let's go to target VPC. Let's modify auto assign. Let's click on this. Let's save, close. So now we are done with the initial setup. Let's go to VPC peering connections. So here what we're trying to do is we are trying to launch instances in your source and target VPC and trying to communicate with each other using the VPC peering connection through the private IP address. So let's go to peering connection, create a peering connection. Let's name it as demo peering VPC. So the requester would be from source, and you're going to do within my account and within the region. And within my region, this is my target VPC. So once you do this, just click on create peering connection. So as you can see here, you can see the requester account and acceptor account. So both are the same, one-on-one, because we are doing within the account. And you can see the requester VPC ID, acceptor VPC ID, and the regions. So once you click OK, you see the status as pending acceptance because you have to go to action and click on accept request. So once you click on yes accept, it's active, right? So now let's go to EC2 and let's launch two instances in two different VPCs and try to communicate and see whether we are able to ping each other or not. Right, let's go to launch instance. So I'm going to select Amazon Linux, AMI, select, so select t2.micro, click on configure instance details. So this instance we are going to launch into source VPC, and by default it has a subnet. You can see the option as auto assign public IP as enabled. The reason being is since we have enabled the option under the subnets, automatically AWS will assign you the enable option here. If not, you can manually select enable option here. Right, so let's go to add storage. By default it provides 8 gig. Fine, add tags. Make sure that you always add tags, which are very important and one of the best practices recommended by AWS. So name, because tags helps you to identify your resources. So let's name this as source VPC instance, configure security group. So we'll name this as source VPC security group. Right, and the traffic is open using SSH on port number 22 everywhere. So since this is a demo, we are just opening from anywhere, but this is not the recommended practice in real-time scenarios. So click on review and launch, click on launch, and let's select the key pair which I've created, launch instances. Right, let's go again and create one more instance. Go to launch instance, select t2.micro, configure instance details. This time we are going to launch your instance in Target VPC, and by default we are going to keep as it is. Add storage, add tags, click on add tag, click on name, mention this as Target VPC instance. Configure security group. So let's mention this as Target VPC security group. Right. Review and launch. Launch. Select a key pair. Launch instances. Right. Now let's go to instances. EC2 instances. Yes, as you see here, all your instances are getting up and running. If you click on your source VPC, as you see here, you have the public IP, you have the private IP, and you have the instance type, availability zone, everything. But as you see here, the public DNS option is not enabled in either of the instances. The reason being this is you have to go to VPC and select your VPCs and make sure that you enable the option hostname DNS, because this creates public and private DNS host names. So make sure you do the same thing for your source VPC as well. Go to edit DNS host names, click on yes, save, perfect. Now let's go back to ECD. Now you will be seeing the DNS host name for both your instances. Click on source VPC and that's it. You see the DNS name here. Right. So since the instances are up and running, let's log into the instance. Go to your PuTTY, copy the public DNS hostname, go to SSH, authorization, select your private key, open. So as you all know that when you launch your Linux AMI, EC2 user is a username. Yes. Let's see whether this particular instance is able to communicate to internet or not. Ping 8.8.8.8. Yes, we are able to communicate. Let's go back to the other instance. Copy the DNS. Go to PuTTY. Copy it here. Go to SSH. Click on authorization. Click on browse. And your key pair. Open. Yes. EC2 user. Yes, you're able to log in. Let's see if we have a connection to the internet. Yes. So now let's see if you're able to communicate. This is the source instance. Let's see if you're able to communicate to the target instance using the private IP. So if you go here, this is your target VP and this is the private IP here. So let's do ping. No, so there's no communication. Let's do the same thing from the target as well. Let's find out the source private IP. Go to your source. So sorry, go to your yes, ping. Nope. As you can see, there is no traffic, so that means we are not able to communicate to each other using private IPs. Yes, the reason being this is you have to change your row table once you create VPC peering connection, and also you have to modify your security groups. So let's go back to your VPC. So here, as you see, we have created VPC peering connection, but when you go to your row tables, there's no traffic here. So you have to go to row tables once again, click on your source VPC, click on routes, edit, add another rule. So all the traffic destined to 10.1.0.0/26 should be reaching out your demo peering VPC. Click on save, and when you go to your target, click on edit, click on add and the role. So this should reach to 10.0.0.0/26, which is the CIDR block for your source VPC, and it should communicate your peering. Right. So once you have changed the row tables, you have to go to security groups. Right. So click on your source VPC security group, click on inbound rules, click on edit, and make sure that you enable all traffic from the IP address 10.1.0.0/26, which is nothing but the CIDR block of your target VPC. Save. At the same time, go to target VPC here, inbound rules, edit, add another rule, go to all traffic, and make sure you add your source VPC CIDR block here. Save. Let's check now, are we able to communicate or not? See, the moment we have changed the row table and configured security groups, now we are able to communicate to the private IP of the other instance. So this is how we do the VPC peering connection between your both VPCs in your AWS account. So in the next lectures, I'm going to show you a demo on VPC VPC peering connection between your own VPCs in another AWS account, and also I'm also going to show you VPC peering connection between the VPCs in different regions. So I hope you like it. Please like it, subscribe, and share it to your friends. Thank you.